Hello guys, my name is Laura De Laviga. My student ID number is 24055311024. Now I will present about wheatstone bridge. First is introduction. Wait. The wheatstone bridge is an electrical circuit used to measure an unknown resistance with high accuracy. It works based on the principle of balanced voltage division between two branches of the circuit. The objective is 1. To determine the value of an unknown resistor, and 2 is to determine the resistivity of a wire. The basic principle is the bridge consists of 4 resistors arrayed in 2 voltage dividers. When the ratio of the resistor in one divider equals the ratio of the other, the bridge reaches balance and the galvanometer shows zero circuit. Okay, you can see in this diagram. This diagram shows the basic wheatstone bridge circuit. It's consistent of 4 resistors, R1 and R2 on the top bricks and RT and RX on the bottom bricks. The galvanometer is connected between points A and C to detect any current flow. A voltage source is applied across the top and bottom of the bridge. When the voltage at point A equals the voltage at point C, no current flow through the galvanometer. This condition tells us that the bridge is balanced. Next is a balance conditional equation. When the bridge reaches balance, the voltage at point A and C becomes equal, so the galvanometer shows zero current. At this balance condition, the ratio of the left side R1 to R2 is equals to the ratio of the resistor on the right side R3 to Rx. This relationship is written as R1 over R2 equals R3 over Rx. By rewriting this equation, we can calculate the unknown resistance Rx accurately. This balance equation is the key principle that makes the wheatstone bridge a very precise tool for resistance measure. Okay, next. The working mechanism. If the positional at nodes A and C are equals, there is no current flow through the galvanometer. By adjusting on resistor typing RC, the bridge can be brought into balance. Once balanced, the value of Rx can be calculated using the balance equation. Okay, now we will talk about wheatstone bridge with slide wire potentiometer. In this version of the wheatstone bridge, the top resistor R1 and R2 are replaced by a long unibar wire. The sliding contact divides the wire into two lengths, L1 and L-L1, which act like two resistors. Because resistance is proportional to length, there's two wire sections from the same ratio as R1 and R2. By moving the slider until the galvanometer reaches zero, we find the balance point. At the moment, we can use the ratio of the wire lengths together with R3 to calculate to unknown resistance Rx. Next, resistance measuring of a wire. Once the unknown resistance Rx is found, we can also determine the resistivity of the wire. Resistivity or ρ relates resistance to the wire's length and cross-sectional area. Using the formula ρ equals R times A divided by L, we substitute the measured resistance, the length of the wire, and its cross-sectional area. This allow us to find to the material resistivity, which tell us how strongly the wire absorbs electric current. Next, we move to the experiment 3, the wheatstone bridge by Team 5. Okay, the equipment used is the wheatstone bridge board, DC power supply, galvanometer, slide wire potentiometer, potentiometer, connecting wires, standard resistor, rule or meter stick, and last is multimeter. The basic experiment procedure is to connect the circuit according to the wheatstone bridge diagram, insert the unknown resistor into the circuit, turn on the DC power supply, adjust the slide wire or resistor until the galvanometer shows zero deflection, recut the balance wire length L1, and calculate the unknown resistance using the operation equation, and the last is for resistivity, measure the wire length and diameter, then computer. Okay, you can see the calculation for the data is R3 is 330 ohm, L1 is 256, L2 is 744, and R actual is 100. Okay, you can see in your screen, Rx equals 330 times 0.344 equals is 113.5 ohm, and deviation is equals 30.5%. And you can see in the table 1 and table 2, you can pause this video to see the result where Rx1, Rx2, and Rx3, and the diameter 1, 0.7, 0.5, and 0.35. And this the diagram you can see is the resistor between relationship resistor and measuring resistance or ohm. Okay, the last is conclusion. The wheatstone bridge is a highly accurate method for measuring unknown resistance. It's operate of the principle of balanced voltage ratio, and it can also be applied to determine the resistance of material, especially wires. The last is. Thank you for your see my video. See you in the next video. Bye bye.